Brainwaves and Ice Bridges: Exploring Arctic Living by Sarah Peach and Leah Robertson. Introduction. With the world population booming, it is necessary to find additional land to use for habitation. Though there are already some populations living in certain Arctic areas, we want to examine Arctic life on a greater scale to determine if it could be sustainable. We will do this through analysis of the ethics of residency in the Arctic through a civil engineering lens and a neurological perspective. What could this mean for construction in the Arctic? Design is ethical when it is sustainable. Developing construction with local materials is both feasible and successful, simply requiring the drive to do this. Blending traditional practices with sustainable designs leads to carbon-neutral results. The Finnish indigenous group, the Samis' traditional construction uses bio-based materials including wooden beams, logs, reindeer skins, boards, turf, and moss for insulation, which serves as a successful case study. Societal customs. Sustainability covers far more than just environmental conditions. It encompasses preservation of local heritage and customs, merging successful design with cultural appreciation. Energy efficiency. The Finnish Sami show that incorporating wood in buildings alongside wind and geothermal energy enhances sustainability in Arctic constructions. This follows Finland's traditional practices and centuries of success. Arctic regions' strict energy and efficiency regulations foster a heightened awareness among engineers and contractors, which promotes sustainable design. Recognizing the unique characteristics of different Arctic areas leads to a tailored design that better serves each region's specific needs. For example, climate change looks different everywhere. Finland's increased snowfall versus the Canadian Arctic's warming trends. Why should we build in the Arctic? Designing with the Arctic's unique cultural diversity in mind promotes successful builds. A life cycle approach to sustainability, gaining materials, the build period, upkeep, and maintenance, and eventually its destruction, minimizes global impact. No single solution fits all Arctic construction, but this model adapts to region-specific concerns. This approach demonstrates that habitability across extreme conditions such as the Arctic can be sustainable and ethical, as less transportation with traditional materials offsets higher energy use.
So to pivot from civil engineering, we now want to look at what does habitation of the Arctic mean for people psychologically and neurologically. To do this, we will look at these three topics. The Arctic is one of the most isolating and confining places on the planet. Social isolation and changes in isolation status were found to be associated with smaller hippocampus volumes, reduced cortical thickness, and poor cognitive function. The hippocampus is the region of the brain associated with memory and the formation of new memories, so smaller sizes of the part of the brain hinder the individual's ability to form memories. In addition, reduction in cortical thickness is associated with depressive symptoms and higher frequencies by those living in the Arctic, meaning that isolation could be the reason for their depression. Alongside the effects of these structural changes within the brain due to long-term exposure to the Arctic, there are also many specific psychological symptoms that come from habiting the Arctic. In a study done to determine the psychological effects of polar exploration, it was reported that these people experienced sleep disruption, impaired cognitive performance, negative affect and interpersonal tension and conflict, reduced motivation, and increased sensitivity to physical and social stimuli. These symptoms resulted after only several months within the Arctic, and these people did not end up living in the Arctic long term. But for the discussion of whether people should live in the Arctic long term, they are almost sure to experience these symptoms. Symptoms such as sleep disruption and impaired cognitive ability both cause individuals to function at a lower capacity. They will not be able to think, behave, or perceive to the best of their ability. Not only this, but negative affect, interpersonal tension and conflict, reduced motivation, and increased sensitivity to physical and social stimuli all cause internal disorganization and dehumanization within the person. Their perceptions on reality will become more tense and conflicting, and the individual will struggle with finding daily motivation. Alongside these individual symptoms, individuals living in the Arctic have also displayed higher frequencies of certain habitat-related psychological disorders. In this same study, researchers also found increased rates of winter over syndrome, polar T3 syndrome, and subsyndromal seasonal affective disorder. These disorders are all based upon the habitat in which the individual resides and retain many of the symptoms previously described. This is significant because these syndromes can only be treated through the change of environment, light therapy, or through specific medications. Because of the structural brain changes and psychological symptoms and disorders, neuroscience states that expanding habitation in the Arctic is not a good idea for the individuals living there because of the severe neurological detriments that can follow.
The integration of traditional and modern design will allow for people to inhabit the Arctic in the future. Nordic residents spend about 90% of their life inside, which means success in Arctic design and construction is extremely important to the mental well-being of these communities. However, if people are not willing to attempt this hyper-awareness of sustainability concerns and awareness of mental health, it would be unethical to design structures in the Arctic. The Arctic could adapt to future life in four main ways. 1. A globalized frontier, which would include unregulated trade. 2. An adaptive frontier, which would have increased trade with strict regulations resulting in environmental control. 3. A fortress frontier. The economy is the focus. There is a lack of environmental regulations and a lack of trade. 4. The ideal solution. An equitable frontier, which would involve improved industry with a focus on hunting, fishing, and sustainable industry, as well as maintaining essential trade. Vernacular architecture, which is rooted in indigenous and traditional local materials, is often misjudged as primitive, overshadowing its sustainability. To succeed in Arctic design, embracing vernacular buildings as model designs is crucial, challenging the bias against traditional approaches.
Now for safety and future for neuroscience. So the terrain of the Arctic makes the construction of roads and other modes of transportation difficult. Arctic cities don't have land transportation means to the rest of the world. There are also not many current medical or emergency services within the Arctic. Though these could be built, it would be difficult to find workers and supplies to make an effective healthcare system. So this brings along the dangers of the lack of efficient transportation during emergency scenarios when quick travel or escape may be necessary. The health of the people will also be limited by their ability to get healthcare in the Arctic. So in the future, this lack of travel leads to further isolation within communities, causing the symptoms I described earlier. And because there's minimal healthcare, these individuals may be forced to live with a poor quality of life and won't be able to get the help they need medically until an expansive system is built.
Should we design in the Arctic? Well, it can't be answered point blank, especially with these two very different majors. However, civil engineering errs on the side of yes, whereas neuroscience errs on the side of no. Therefore, design can be implemented. However, the brain makes it essential that a careful mindset is used and is implemented. Sources: